Wow, we're still taking.
Yep, people still coming in.
How are you doing, Anand? Yeah, I was just saying hi, Anand.
Yeah, hi. Sorry, I didn't notice.
No problem. Go ahead, Hardik.
Yeah, I was just mentioning that we have kind of reached a limit. Teams only
Really?
supports like 300 people. Yeah,
Oh.
I think other people will have to kind of wait and watch the event later on YouTube. For now, we didn't expect this big of a response.
Wow.
But yeah, next time we'll figure out a better platform to host these events. Arohi, we can get started.
Sure. Sounds good. All right, so I'll quickly start with a brief introduction. So I'm Arohi. I'm one of the co-organizers of this community, as well as being the head of operations at Incubite. So at Incubite, we are a software services company. We work on the clean code practices and care about really well-crafted software. So we are the founders and the sponsors of the Software Craftsperson People India community, right? So before we dive right into the event, I just wanted to take a couple of minutes to reflect on what this community is all about and what we are here to do, just for the people who are here for the first time, who haven't attended talks before. So basically, we are a group of really passionate people in the community who are here to spread knowledge and to spread information about how to create well-crafted software. We organize expert talks like this one, as well as roundtables, as well as workshops to help the community get better at the craft. We are a completely not-for-profit organization, and we do this only to help people who are truly interested to build better software. Having said that, I think, Anand, that's about it for me. Over to you. Let's start with a quick introduction and then dive right into the subject.
Can I start?
Yeah, please go ahead.
Yeah, just a minute. Let me share my screen again. Let me know if you can see my screen.
Yes, I see it.
Great. Yeah, thanks a lot. It's really an honor to speak with such a large audience, and I really I'm a programmer at heart, and I love writing elegant and clean code. And when I saw a software craftsperson group, I was kind of really delighted to kind of see like there are people who are such a large community trying to discuss about ideas around that. So I thought today I'll share a quest that I've been through, a quest for an elegant code and what it led to. So so let me kind of start with introducing myself first. So my name is Anand. I've been crafting beautiful software for about 2 decades now. I built web.py, a microwave, I co-authored web.py, a microwave web framework in Python, a software called Infogami, and built Open Library and Internet Archive. Currently, I am working at FOSS United Foundation, building my own school, an online platform to learn programming in a fun and enjoyable way. So I want to kind of start about talk about what is an elegant code first, and then kind of talk about a quest that I kind of went through quite recently. So I really like this quote from Tower Programming. It says like a program should be light and agile. Its subroutines connected like a string of pearls. The spirit and intent of the program should be retained throughout. There should be neither too little nor too much, neither needed loops nor useless variables, neither lack of structure nor overwhelming rigidity. I think it's really kind of captures the spirit of what an elegant code really is, right? I mean, so So one thing is really important is to kind of see that spirit and intent of the program is kind of retained in the program. Okay, so when you look at a program, read a program, you really kind of connect to what we're trying to solve, etc. So at the core of it, it's really like we're writing programs for people to read and understand, not just for machines to kind of execute and produce the result. So having said that, I want to kind of take you through a quest that I went through recently, right? So I went to a library nearby with my daughter, and I kind of got hold of this book. It's called The Right Angles. It's also put in the slides there. Okay, so it's a book about mathematics from Ajay Premji University, and I really kind of fell in love with the cover picture that's there. So I thought, let me kind of see if we can actually write a program to create that. So, and what I ended up doing was I ended up kind of creating a program in P5.js, which is a creative coding library in JavaScript. But I'm going to quickly show you like what it kind of feels like. So this is what I kind of ended up creating. But if you see, the code is kind of quite complicated, right? I mean, if you see, it's some 40 lines of code with sine and cos and whatnot, with a bunch of for loops and etc., right? I mean, it works, but it's not really that elegant, right? I mean, I wasn't really happy with what I could come up with. And then I also kind of extended that a bit to kind of tessellate that and to kind of create the pattern which actually I saw in the magazine. But I wasn't really happy with this code, right? So around the same time, I've also been working about creating a course for introducing programming. And so this was also kind of going on in the background. Like I wanted to kind of solve this program more elegantly than what I could have solved. But if you look at it, right, I mean, it's kind of quite complicated, right? You can't really make out any relation between what is there in the left and what is there in the right, right? I mean, in the left, you have like loops and stuff, and right, you have this kind of nice looking pattern. There's no correlation between these two, right? I mean, can you think of an elegant way to kind of solve the same problem? So what I did was like, I ended up creating a creative coding library called Joy in Python. So I'm going to kind of talk about what is Joy a bit, and then say how the same problem could be solved with Joy. So Joy is really very tiny creative coding library. So you can actually say a shape equal to circle, then show C. I hope you can see my screen. Can someone confirm that they can see my screen?
Yeah, they can see.
Yeah, great, thanks.
Yep.
So if I I'm executing, oops. Sorry, I'm showing S. So it's a circle. So this library has actually 3 to 4 shapes. It has about 4 shapes. You can draw a circle, you can draw a rectangle, you can draw a line, and that's pretty much it, right? I mean, you can also specify, for example, if you're drawing a circle, you can specify the radius, how much radius that you want, a smaller circle or a bigger circle. Or you can specify also the width, the coordinates. You want the center not to be at the origin, but x to be at 100, so that would kind of get moved. So it has like 4 shapes: circle, 3 shapes: circle, rectangle, and line. And one interesting thing that this can do is it can actually applies a bunch of transformations to it. You can so let's kind of just look at this one. And you can say scale this by, let's say, 0.5, or I'll actually use a rectangle, right? That becomes small, or I can actually make it bigger, that becomes really big. Or I could translate this with x equal to, let's say, -50, it will move to the left, or y equal to -50, then it will move to the bottom corner. Yeah, I think this should be better. Okay, and you can also scale this. We have seen scale. You can also rotate this. Sorry, just a moment. You can also rotate this by, let's say, 15 degrees. That rotates it by 15 degrees. Now, so one thing that we could do with Java is can apply some of these repetitions, these transformations repeatedly. So you could say repeat this, let's say 10 times, and you rotate 15 degrees or rotate 10 degrees. So it starts turning around, and 10 times it kind of rotates that. So if we take a line instead of a rectangle and rotate it 18 times by 10 degrees, it will complete half revolution. That actually becomes you get a star. Right? I can do the same thing with a rectangle, but I'll take width and height the same to make it a square. Since it's square, I don't really need 18 times. I can just need to do it 9 times, but that's okay. So you actually get a kind of flower, which is just a single line of code. So one thing interesting that you can do is you can actually combine these transformations, not just a single transformation. You could say rotate, but I can also scale this with 0.9. As you can see, a nice pattern is kind of emerging here. So let me kind of make it rotate 5 degrees so that I get more of these. Okay, and maybe do it.
Hey, is it just me or is it Anand's screen that is stuck?
Anand's has
Yeah.
been stuck.
It's stuck. Seems to be. Maybe internet issue on his side. Let's wait for a few minutes, see what happens. Seems like he has dropped off and he's back.
Hey, you're on mute, Anand.
Yeah, I think it's probably, I think something wrong with Meet. It just kicked me off.
Oh, okay.
Can you see my screen now?
Yeah, we can see it.
Okay,
Yes.
so I don't know when I got cut, but let me kind of just repeat where I started, right? So if you look at this, right, this is a single line code that basically creating the same thing that took me this close to 40 line ugly JavaScript, ugly code, right? I mean, nothing to do with JavaScript here, but the way I was doing it was really too low level. It was going over loops and writing math and sine and cos and whatnot. But if I kind of just come here, I mean, and see this is actually, I would say, a really elegant way to kind of solve the same problem. Okay. The reason we were able to do it because we were able to abstract the right elements out. For example, the library, if you see Joy, it doesn't have too much, right? It actually has very simple constructs. It has 3 shapes and four transformations and one way to repeat and combine stuff. That's all. And this is what I could create. Okay. Now, let's start from here and actually see what else we can do with this and see if we can create some elegant code using this. So let's see now. So what I'm going to do is just to give me a moment. Sorry, yeah. I'm just trying to just give me a moment, please. Yep. So we just got just one of the shape, but let's kind of try to see if we can actually create what actually we see in the shape and see what does it take. Okay, what does it take to kind of create that one? Now I'm going to see how to put two of these two things together. So what I'll do is I'm going to write two functions beside. So what beside does is it takes two shapes and puts one next to each other. Okay, so we're assuming that we have each shape is taking full size, which is 300 by 300 pixel. Our canvas is 300 by 300, so we're assuming that it's going to be that size. So what I'm going to do is A1 is I'll take A, it's the first shape, and then I'll make since we're keeping one beside each other, I'll squeeze it by make it half in X direction, and I want to move it to the second half, so I need to translate it by -75. So the total is 300, so it's in the center, so it has 150 to the left, so it has come to the middle of that, so it's -75. And I'll do the same thing now for B, so I'll say B1 equal to B, and then you do the same thing, but this time you translate to the other side, and now return A1 plus B1. So it combines them, and then it's okay. Let's now see if we can actually say, so I'll say S2 equal to beside S and S, or let's kind of let's see, let's put a circle and rectangle together and then see what happens. It's a circle and rectangle. So we see we get a circle on the left and the rectangle on the right. Okay, so it gets squeezed because we're only scaling in one direction. Now let's see the one. What we want to do is now I want to put one below the other, not just besides. How would you do? You do it with Y. You get the same thing. You have to also translate the Y. Now let's see if we can fit one below the other. What happens? You know, something is going wrong here because the circle is supposed to be on the top because that's the first one. That's because the way X goes from left to right, but Y goes from bottom to top. So we have to kind of flip this order. This is going to be right. So now we got these two things below and right. Okay. So now let's kind of see now. What we'll do is I call this S. Okay. Maybe I'll call this R, which is a bunch of rectangles. Okay. Now let's say beside R and R. Let's see what happens when I put R and R together. That's not quite fun. Let's see if we can put 4 of them. So I'll create a function called grid. Takes 4 shapes A, B, C, and D. And then how do you create a grid? So below, so you put A and B beside each other, and sorry. C and D beside each other and put both of them below each other. That okay. So now let's see if I can actually make a grid of circle. Let's take a red circle, a blue circle, a green circle, and a yellow circle. See if we put in a grid and see if that works. There you go, right? So now if you see how we created a grid by actually using these primitives below and beside. So we got this. Now we can do something interesting. We can actually say put that in the grid again. Take the S and put this all of them in the grid. So we'll actually get a lot more, and we could try repeating that once again. And we're going to get a lot more dots, colored dots. Okay, but that's not what we're at. Okay. Now what we really want to do here is now not a grid of circles, but we really want to see if we can actually put R in the grid. Okay, that's not really fun. Okay, but that's because we're only using not the full size 200. Let's make it 300. That would actually start now looking better. This is fine, but it's not quite what we really wanted, right? If you see here, this is kind of quite different from what we got. Okay, so that's because this one kind of came to the top. So what we need to do is we need to kind of flip that. So let's kind of write a function, flip. It takes the shape S, and then how do you flip it? You kind of flip it around the x-axis. So you scale it with x equal to -1. Now let's see if we can actually call R2, which is R flip of R. Okay. So now let me put R2 here and see if that makes any difference. Looks like we got it right. Okay, and then this should also be R2. There we go. So we got the shape that we're really kind of looking for. So if you look at the code, if you forget about the primitives or the utilities that we're going to create, right? So we created the shape R and flipped it once and then put them in a grid, and that's what you got. Okay. So if you look at this 4-line program, right? Assuming that the primitives that we created are not really part of the program, okay, it's really elegant, right? Because the intent, what you're trying to do is crystal clear in this program, not like compare this with the JavaScript version. Well, I mean, there's nothing wrong with JavaScript, but the version without using this library, right? But if you see, to kind of tie it like that, we ended up actually creating in a loop, nested loops and all that, but can't really correlate to what's kind of happening here. Okay, but if you look at here, we're just putting them in a grid. That's really kind of very nice way to do that. Okay. Okay, now we got these things so far. Okay, now let me see if we can do something even more than this. Okay, so what I want to do is, yeah, well, I think we can actually even see if we can actually do this further and then see what we get. Right, I mean, if we run this again, do we get something interesting? There you go. Yeah, right. So I kind of tried the same thing again. So you got even more interesting shapes. Okay. Okay. Now let's try something else. Okay. Now what I'm going to do is I'm going to get you an interesting shape, and we're going to work with that. Okay. Let me say. Okay. So I'm going to kind of comment this part out because we're going to try. Okay. So I got a fish for you. I don't know if you've ever seen this fish. It's kind of went all the way up because the shape is kind of drawing in respect to origin. So let me kind of move the fish back slightly here. So I just translated. So the figure is of size 260 by 260. So I'm kind of doing some translations to kind of get it into a shape that you can actually use. Okay, right? Okay, this also kind of the shape is with the size of 260. I really want it to be 300 to fit into 300. So what I'm going to do is I'm going to also take the same fish and scale it with slightly larger so that it takes exactly the 300 width that we actually have. Okay, so this is a fish that we actually have. Now, if you want to, if you can't see it fully, let's scale it by 0.5, or and so that you can actually see it completely. That's a fish that we have. Okay. Now let's see if we can actually try something interesting, elegant stuff with the fish. Okay. So I'm going to try some interesting things, some stuff here. Okay. So I'm going to create a fish too. Which is the same fish. Rotate it by 45 degrees, and let me show fish 2. Okay, it's kind of here. So I really want to kind of so what happened was we took a a square and rotated that. So the length of that kind of became slightly bigger because the side was there before, and that kind of now the diagonal kind of became horizontally. So it's kind of increased it by root 2 times. So I'm going to scale it down a bit to reduce the size. Square root 2 is kind of already defined in the system. Okay. So that kind of I squeezed it a bit, and still centered around the origin, but I wanted to kind of move up. So what I'll do is I'll translate it to 150 degrees. Okay. Sorry, x by 150. So it moves up. I also like to flip this around. I'll explain why I flipped it. Okay, later. Scale y equal to -1. Sorry, x equal to -1 to flip this. Okay, so now I have two things, fish and fish 2. Let's see something interesting here. Okay. Okay, so we have these two basic shapes. We're going to rotate, do a lot of rotations now. So I'm going to kind of keep a handy function called, instead of typing rotate 90, I'm going to call rotate and takes a shape. Right, so it kind of made it a small utility function. Okay, so let's see now what happens if I rotate it. Okay, so if that's a fish, if I rotate the fish, what happens? That comes to the side. If I rotate it once again, that comes to the other side, and if I rotate it once again, that would come to the other side. Okay. Now, I'm going to create a shape called U. We'll take the fish 2, add rotate fish 2 plus rotate of fish 2. Three times rotation, the same fish 2. Okay, now let's see how would you look like. So I'll kind of scale to 0.8, just to kind of scale slightly down so that you can see. As you can see, there's some interesting property here. It's kind of just fitting in really nicely. Okay, all of them getting interlocked really well. Okay. Well, I'll leave why it's getting interlocked to your imagination. I'm not going to get into those details. Let's try something else. Okay. Now we got U. What happens if I actually say x equal to? I'll put all of them in the grid. U. And what would x look like? Right? And what if I go one more level? Y is grid of x. So just putting, we're just using this function that we defined to kind of create even more complicated stuff. Can you see that what we're trying to do? We kind of got a very nice tessellating shape. Okay. Well, that's not it. Okay. So there is a lot more coming up. Okay, that's really kind of really cool. Okay, but let's not stop here. So what I want to do is actually create a pattern with actually 9 shapes tessellated. So I actually wanted to create a 3x3 grid, not a grid, but actually I would call it a nonet with 9 shapes. To put 9 shapes there, we need to kind of create more abstractions. So what I'm going to do is I'm going to go back and take the beside and the below. Right? I take these two things here, and I'm going to kind of call it beside 3, which takes 3 shapes instead of 2, and below 3, which takes 3 shapes instead of 2. Right? Okay. Now it's going to be C1 here. Now the scale is going to be 1/3, not just 0.5, because we're having 3 of them. And if you see here, we don't have to translate this one. This is going to be at the center only. This one is going to translate it to -100 because its total width is 300. this is going to move 100 to the right, A is going to move 100 to the left. Similarly here, would so I would actually rather copy this and replace here so that I don't have to change the numbers. So it's going to be Y, translate Y, but since Y is going other direction, we'll translate the first one to 100 to go up and the last one to go to the bottom, B1 plus C1. And okay, now just like we had a grid, I'm going to create a something called non-net. Okay, non-net means non-net to kind of say line shapes. I'm going to call it. I'm going to run out of variable names. PQR STU VWX. Okay, I think it's still safe. Okay, so below 3 and then besides 3. So let's start with P, Q, and R. STU. Yeah. VWX. Okay, right, that creates non-net. Okay, now let's go back and I'll say C equal to circle, and I'll say S equal to non-net. C. Not do this one now. I'll see if we can actually create 9 circles in a shape. Then we'll see how to use how to do some magic with the fish using the 9 shapes. Let's see. Are we getting, okay, great. So what we're doing here is we created a function non-net that takes 9 shapes and then put them in a 3x3 grid. Now what I want to do now is let's see what can we do with these fishes. Okay. So if we take okay, so what I'm going to do is I'm going to create a blank shape. Well, how do you create a blank shape? Not sure. I'm just going to fake it. Okay, R equal to 0, stroke equal to none. Okay, I don't know how to create a blank shape, so I'm creating a blank. I'll say underscore equal to blank just so that I don't have type so much. Okay, so what I'm going to do now is let me see if we can put a fish here and then see how does it look. Okay, so there's a fish and all the circles there. Okay, now what if I put all fishes? I think we'll get the same thing. Okay, now what I'm going to do is before I get there, let me kind of take a small diversion and the plus that I kind of used here, right? Well, I think that should be good enough. Okay, I'm going to create a new shape called T. Okay, I'm going to say T is take the fish and fish to add together and show T. Let's see what we get here. Okay, that's too big to see. Okay, so if you put the fish and fish 2 together, they get interlocked. Okay, what's the magic happening here, right? So if you see, we scale it down by by root 2. Okay, so the proportion of the wing here and so this which one is this? Yeah, yeah, the wing here and this one are in the ratio of root 2, so that they get actually interlocked really well. Okay, so there's a lot of math kind of went into doing this. Just to clarify, I didn't create this shape. This is something that I've copied from, I guess, a 50-year-old painting. Okay, so I'll get to the details, you know, once I finish it. But it's not something that I've made. Okay, I've just kind of steal this idea from some I guess a 50-year-old painting, 50 or even more. Okay, but so let's kind of get back. Now, can we? There's a gap here, right? Can you see if you can actually put that again there? Okay, So what I'm going to do is if I put rotate fish 2 again and add that might see how does it look like. Okay. Oh, it's coming on this side. I want to put on the other side. So I do 3 rotations to kind of go there. Let's rotate. Rotate. All right. Okay. Let's see. Can you see that? That got interlocked between those 2 again. Okay. It's not this normal fish. It's kind of quite an elegant fish. Okay. So, but let's see. Now we got T here. And so we have, we're trying to create a non-net, right? So what I'll do is now here, I'll put the U shape that we created here and then put blanks here. So that
I'm guessing teams threw him out again.
Yep, we are getting too many people today.
Maybe we should try something like YouTube Live or something next time.
Yep.
We probably should, yeah.
Yeah, agree.
hey, can you hear me now? I think I lost.
Yes,
I got kicked out again. Okay.
Yeah, can hear you.
Yeah, I don't know when I got lost, but I'll just repeat from a few minutes back. Okay. So what I was trying to do was I was trying to create a shape called T, which is this interlocking shape, and trying to kind of go and create a tessellation of, a grid of 9 shapes. So I put this U shape in the middle. What I'm trying to see what can actually keep it around this, right? So what I'll do is if I try to put the shape T here, that's kind of too big for this. Okay. So what I'll do is I'll call this a side, and I'll make a grid containing and T. Okay. And
I think Teams has a cap of 500 people. That's why Anand is getting kicked out.
yes, I got kicked out again.
Sorry.
I think it's just instable. Teams is not stable. I believe it's not really.
Yes, we are hitting the cap.
Yeah. Yes. Okay. So let's see now. Okay. So I'm trying to kind of see if we can actually put the. I try to kind of put combining the shapes of U and T with some proportions. I kind of get it interlocked at that level, at that place. Okay. Now, if I actually put it here again, yeah, let me see if we can put it again here. Then
Guys, I think we need to stop admitting more people to this. So if you see a request to admit people, please don't click on it.
Yeah.
Really sorry. It just kicked me, not only kicked me out, but it also logged me off, and I was trying to log in and kind of get to there. It's really quite painful. Can you see my screen now?
Yes,
Yeah,
Anand,
yeah.
I'm sorry about this.
No. I think it's also like I'm actually trying to run Teams on a Linux machine. That could also be the reason. Yeah. Okay. So hope this works now. Okay. So just to recap, so we're trying to kind of put these fish into a 3x3 grid. We tried to kind of put a T shape here. We were able to put one of that, but when I tried to kind of put the other one also here, that didn't work. So let's kind of see if we can rotate that and kind of keep it. And as you can see, that fits it really well. Okay. Now, what can we keep it here? Can I keep the same side here? That wouldn't really work. But I could rotate this and put it here. See if that works. That fits in really well. Okay, let's see the bottom. What can I put? Rotate twice and put the side here. That kind of goes in really well there. Okay, and side. I think that should go in. Right? Okay. I think I closed one more mistake. There you go. Right? Now let's see what can we put in the corner now, right? Okay. So let's see if we can say corner is, let's create a grid. Let's go. Okay. Let's see. So it's an empty, so it won't, nothing would change here. Okay. But what I'll try to do is I'll try to see if we can actually keep the same view here. You can see that's kind of fitting in really nicely. Now I could do the same thing all around. Okay, so I'm sorry. We have to rotate this again, right? So if I yes, so this has to be rotated once to kind of keep it, otherwise that wouldn't look nice. So you rotate it once. We're fixing the left bottom left, then the bottom right. Rotate that twice. Rotate the corner. Let's see if that's working. Seems to be. This you have to rotate 3 times. Rotate the corner. 1, 2, 3. There you go. That kinds of fits in. Okay, so let's see what we've done, right? We've taken 2 shapes, U. So this all we can actually kind of comment out. Okay, we started with a fish, then took a fish 2, which is a scale version of the same thing, created a shape U, which is a fish, put it 4 times and as a cycle. Okay, then we created a shape T, which is fish plus the fish 2 twice. Then we kind of started escalating it and kind of created this wonderful shape. Now we can actually go one step further also. But I think I'll stop here and actually kind of see if you have any questions before we kind of and then decide whether you want to kind of go further on this. Okay, so I'll pause here, and I think we have seen a quest for elegance in and then reached out to creating the joy, and kind of now we have seen solving, I think, which is an elegant solution to a problem that we're trying to solve here. Okay, so I would pause here and then take if you have any questions. Okay, so this can actually be extended to kind of have multiple levels, but for the sake of leaving more time for questions, I would stop here. Okay.
Great. I must say that this generating this kind of pattern step by step really kind of looks
so,
beautiful and feels satisfying as well.
Yeah, so let me kind
I
of.
think
Sorry, go on.
A lot of the people might be wondering how they can also try this out.
Sure. Okay. Yeah. So I'll get to that. Okay. So before that, let me kind of give a background about this picture. This picture is created by a Dutch artist called MC Escher. This is called Square Limit 2. You can Google for Escher paintings. You will find this. Okay. So so this person has been quite a genius, and I don't know if you've heard of this book, God Will Escher Back. One of the popular books. People who love Lisp and recursion, etc., would have heard about that book. So this is the same Escher that's there in the title of that book. Okay, and how you want to do this, right? So, like I told in the beginning, I'm working on this platform called learning platform called Mon.School. So this is the platform. Let me kind of save this here. Okay. Now, if you go to Mon.School and look at the sketches, you'll actually find, yeah, I think it's taking a while to kind of generate this, but it's supposed to kind of come in. Maybe it's a bug. Okay, but you can click on it and actually see the kind of stuff I have done here. Okay, so you can head on to Mon.School and Mon.School and actually try this out yourself. And I have created a course called the Java Programming to actually learn programming in a fun way, where actually this course is created as an introduction to programming course, where students actually learn programming by actually creating these shapes. Okay. Now, one of the interesting things about this course is, or rather, when people learn programming and they begin, right? I mean, it's really very overwhelming because there is so much of new things to learn. There's so much of syntax and whatnot, right? Okay, there's so many keywords for loops and what, etc., right? But this course focuses actually not really on the syntax of the language, but more on actually these ideas. How do you combine simple ideas to complex ideas? So, for example, until we reach the chapter 5, so this course is in Python, but until we reach chapter 6, we don't even use a single keyword of Python. Okay, right? So until half of the course, we actually learn enough programming without even using a single keyword, right? If you kind of look at where is this one? Yeah. So if you look at the first program that we wrote, right? I mean, I think not this one, but I think it's, yeah, this one, right? So taking the rectangle and rotating it, etc., creating that shape, that doesn't really require any keyword, right? You're just calling a function and combining them using different operators. That's all. Okay. So if you really want to kind of try these kind of things, head over to Mon.School, create a sketch, or go through this course. I think that would be a way where you can actually try these things yourself. Hope I answered your question.
Yep.
Any other questions?
Yeah, if anybody from the attendees has any questions, they can ask them via chat and we can detect them.
Hey Anand, I had a question.
Sure.
So, create a tool that you have created, first of all. Is there a way to export these images, like other than just taking a screenshot, or any other way of getting those
Yes,
images
okay.
exported?
Yeah. So the thing is, like, this actually also you can run this independently, for example. Okay. So I'll quickly show this. I'm running a Jupyter lab instance here. Okay. Oh, I need to hold on. Give me a minute. I'm just trying to see if you can. I don't remember what was here. Okay. Yeah, just a moment. I'll show you how we can actually use this and write a program to kind of save this. Okay. So I'll just create a new Python notebook. So from joy import star. Now let's try the same thing that we've done, right? Take rectangle. Width is 300, height is 300, and you repeat 100 times. Rotate by 5 degrees and scale it by 0.92. I think that's correct. Right, so I got R now. If you look at R, let me show you that shape. But I can say R dot as SVG, that gives you an SVG that you can take it and actually use it as an image. Okay, so that kind of yeah, that's an SVG that you can take and write to a file. So with open a.svg in write mode as f dot write. When you can just write it, so that gives that image. You can take that and write to a file. Now actually have so I have this thing. I can actually open it and in the browser and see that, right? So you can write the output of any of these images into a file and then use it. Okay. So though it's kind of is integrated into the platform here, you can actually use it as an independent library and use it to create your own stuff and save it.
That's really nice. Thanks.
There was a question by Narendra. He was asking what kind of inspiration, what inspired you to approach programming in this way? Okay,
so that's a long story. Thanks for asking that question. Okay, so last year we decided to. I was trying a startup that didn't work, and we kind of shut it down in the beginning of last year. And I was figuring out what do I want to do next, right? I mean, I was always passionate about teaching. I teach programming courses professionally, but I was kind of trying to do something different. Okay, so a friend of mine asked me if I can teach programming to some school students, right? So I asked them if they already know any programming. They said they already had Python in their syllabus, and they've been they had it for almost a year. Okay, but when I spoke to them, they were not really excited about programming at all. Okay, then I started thinking, right? I mean, what's an interesting way to kind of make people excited about programming? So I thought learning by actually creating something interesting that you can actually connect to would probably be an interesting idea, right? So then what I did was I took a week course, 1 hour each day, creating something with P5.js. And by end of the 6th day, right? I mean, the kind of stuff they have created, these are school kids I'm talking about, right? Okay. There's a group of, I think, about 8 people. And all of them, they were really excited about programming. They created interesting stuff. And that got me hooked, okay, right? I mean, so I realized, like, earlier I used to believe that Python is really very good programming language for beginners and all that, okay. Then I realized it's really not the programming language that is important, right? Because like, these people already got introduced to Python and they were at it for almost a year and they didn't really get excited about programming, okay? But the moment I kind of showed them something, though it was in JavaScript, and they got really excited by end of 6 days, okay, by spending 6 hours of time with them, okay? Now, what I took away from that was basically it's not really what programming language that you're working with, but what kind of ideas that you're exploring through that, okay? So that was the inspiration for actually starting on this journey. So after that, I kind of continued experimenting with that to see like what else can work, right? So I started playing with electronics, tinkering with sensors and stuff, because that's really also exciting because people get connected to that very easily, right? For example, just clap your hands and actually can you blink the light? Can you switch on the light or fan by just clapping your hands? Okay, so can you make things in the physical world move by actually doing some actions? Okay, and there may be some circuits or code kind of behind, right? I think that so that was the other thing that I really found exciting. So these are the 2 ways I found are interesting ways to introduce programming to beginners, and for whatever reason, I kind of continued explored a lot more on this path, and I'm sure the other path is also exciting, but still unexplored.
Yeah, the visual aspect really kind of adds to the whole experience.
Yeah.
I think there was someone probably coming from a data analytics perspective and was asking if this is related to MATLAB. I would add to that question and ask if, is this just for circles and rectangles and lines, or can we actually represent data with it as well?
Okay, so the reason I created this library was I wanted to teach an introduction to programming course. Okay, I could have started with JavaScript. Okay, but if you see JavaScript, the hello world program that you write, so let me kind of quickly show you what I meant. Okay, right? If I go and actually create a new one, okay, this is the hello world program that you can actually create. Okay, right? If you draw, it will actually just puts a, this is hello world program. Okay, but to explain this to someone, to a beginner who has never programmed before, because I have to explain what is a function, what is create canvas, what is back. Look at so much of syntax that's staring at you. So I really wanted the hello world to be one-liner or at max two-liners. Okay, a person who doesn't have never looked at any program in their life before should be able to understand it. Okay, that's the reason for creating this library. Okay, so then this library is actually not feature complete in that sense. It's actually as minimal as possible, right? I mean, it only has the basic minimal things required for you to kind of get going. Okay, and I think that's also the beauty of this library, right? I think people say elegance is not when you can add more to it. It's when you can't remove anything else from it, right? That's when it's called elegant. Okay, so in a sense, the joy is a kind of very elegant library because it has like 4 shapes, 3 transformations, and 2 ways to combine them, and that's all. There's nothing else. Okay, and that's all. You can say that's all, but let me kind of show you what all things actually kind of possible. Okay, so we kind of ran a competition called Kodipukkalam for Onam, and can you see like all these things are actually created using Joy? Okay, so this is a competition that we ran for children, for people in Kerala for festival, for Onam festival. So they have a tradition of creating these flower decorations for Onam, and we said let's see if we can create it with code. And these are the kind of some of the entries that people have created. Okay, and if you can see, like it's kind of mind-boggling, right? I mean, these are the people. Some of them are first-time programmers, and some of them actually wrote code in a way that they don't use a for loop. They don't use. It's actually kind of very down to earth kind of code, right? It's a flat code reading line by line. Okay, and Joy kind of made it possible to kind of create some of these kind of things. So I think I would say this is the purpose of this is to kind of get people understand about the importance of thinking like a programmer. Like, I mean, how do you combine things, how do you abstract things, etc. Not really to kind of solve a real problem. I think people, once they kind of learn this, they should be able to continue doing other things. So that was the kind of background for that.
Yeah, that makes sense. So just a bit of remark, if you are looking for alternative of MATLAB, this is not it, right? This is more for a learning purpose. It's about elegance and beauty.
Yeah, I think if you're looking for alternative to MATLAB, you already have Python and Matplotlib. You don't really,
sure.
And so many other libraries, right? I don't think you will miss MATLAB. Yeah, any other questions?
Are there any active issues or any work that is pending on Joy? Like, are you on GitHub or something?
Yes. Okay. So you can go to Mon School. You will actually find a link to that as well. Okay. So we're actually, I think Joy. There are a couple of issues. So we're looking for to kind of add a better documentation for Joy and make it more stuff. For example, something that I really wanted to do was to kind of create a Twitter bot for Joy. Where you just tweet. See, Joy is very minimal, right? You just saying enough code, tweet the code, and actually gives back the image. So I was thinking of ideas like that. But if any of you are interested to kind of work on Joy or something related to that, you're always welcome. Just ping me, and I'm happy to get in touch.
Awesome.
So just to kind of add to that, right? So so this is my email, anandology@gmail.com, anandology on Twitter, and probably on LinkedIn as well. Okay, so you can just ping me in these places, and I'm happy to kind of get in touch and see how we can work together. Really kind of looking forward to kind of work with a lot more people and help people and programming, right? Okay, so then, I mean, I want to kind of add a small plug here before we kind of you close the session, right? I mean, so I've been working on MonSchool for quite some time, and we're actually looking for people to create interesting courses on MonSchool. So if you kind of see, there are a bunch of interesting courses, but we're actually looking for even more courses to come on the platform. These are some of the courses that are kind of coming in. We also have, I mean, not all courses are kind of listed here, but so we have a grants program where we are giving grants for people to create new courses on MonSchool. There's 1 lakh grant to create any new course. So we're really looking at people who are passionate about programming, who love the craft of programming, and kind of help other people to learn. Okay, so if any of you are excited about an idea like that, please ping me offline. Okay. Yeah. Sorry for the off-topic plug, but yeah, I'm open for any more questions.
I think we don't have any more questions relevant to the topic. I don't see anything. I guess we can conclude the talk. We're already above.
Yeah, sure. Yeah, so I think, I mean, I don't have much to kind of say, right? I mean, the whole idea was the quest kind of started with this, right? I mean, I started looking at this and I wrote something that wasn't elegant enough, okay? So I wanted to kind of solve it in an elegant way, and then that kind of led to so many other things, right? I mean, I didn't kind of start going just to kind of solve that problem, but that was always behind my my thoughts when I was kind of doing this, right? So when I created a Java programming course, it went through 4 iterations before we kind of ended up with Java library, okay? And then I felt I had that aha moment, right? I reached where I really wanted, right? So I could write the entire thing that I was kind of struggling to kind of make it elegant for so many, for still so many days, right? To a single line, and I really had that aha moment, okay? So I think in a sense, I conveyed a sense of what an elegant code is, okay? And some of the journey that I went through. Hope it helped you to think about code in a slightly different way through this. And thanks a lot for attending. And you can always reach out to me if you have any questions. And those are my coordinates. Thank you so much.
Really, thank you, Aaron, for spending 1 hour with our community. We are always looking forward to hearing more and more about software craftsmanship, a beautiful code from people like you. And I believe this was the session where your words kind of reached almost 450 people, and that's really a goal, like a milestone for us. So thank you very much for being with us. Thank you all the participants for attending, interacting in the QA session at the end. Anybody who kind of missed any bits of the talk, our entire recording will be available on our YouTube channel next week, and we'll be sharing the link on via our Twitter account and LinkedIn. So look out for that. And yeah, thank you for being a good audience.
Thank you so much. Thanks, everyone.
All right. Hopefully see you everyone on our next session next month. Thank you. Bye.
Thank you, Anand.